This is video 58 on MicroPython LVGL embedded solutions. Recent viewers with the Waveshare ESP32S3 LCD 4.3 display cannot run the simple test matrix program. We discovered that the RGB display module changed slightly in recent MicroPython LVGL firmware builds. In this video, we show the simple update to fix the display driver. And since this is easy, we also show how to update to the latest firmware. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to update the display driver which configures the Waveshare device. We will demonstrate the driver's issue and update it. Since this is quick, let's go ahead and update the firmware. The firmware and code files are at the GitHub site that is mentioned in the description and endnotes for this video. Our example is the test matrix LCD bus program, which calls the display driver on the flash. The test matrix program was written for the LCD bus firmware when it was MicroPython 1.24 and LVGL 9.2.2. But by late August, people were building MicroPython 1.25 firmware with LVGL 9.3 using the special LCD bus software approach. And it turns out the maintainer made some small changes. Let's run our test matrix program on this new firmware so that you can see the error. We have Thony up and we've loaded the test matrix program into Thony. Let's run the program. We'll click the green run icon. Oh, we see the error. No module named RGB display. Why is that? Let's take a look at the modules on this firmware. When we do, we're looking at all the modules and we see there's no RGB display module. Instead, there's an RGB underscore display underscore framework module. The maintainer must have changed the name of the module from RGB display to RGB display framework. Let's see if we can fix that. Let's look at the code for the display driver. When we see line 13, there's an import for RGB display. Let's change it. All right, let's import that module and see if we've got everything right. All right, we can now look at RGB display. When we press the tab, we get a list of the class functions in the module. There's one more problem. On line 50, RGB display no longer has RGB display, it has RGB display driver. Let's fix that. All right, that should fix the display driver. Now that we've updated the display driver, let's see if our program will run. We've clicked the red stop icon to make sure that we're now looking at a fresh firmware. Let's click the green run icon. Okay, the test underscore matrix underscore LCD bus program is running fine. Let's stop it and run the button program. Okay, I've loaded the button program. Let's run it. Okay, the button program is running. And you see a button in the middle of the display. We can press it, and as we do, the click messages show up in our shell of our Thony. Okay, now that the display driver is fixed, let's update the firmware. First, let's explain the MicroPython firmware. The LVGL library is C code. We build it into the MicroPython firmware to allow us to import it into our MicroPython programs. There are two ways to do this. The standard way uses the LV MicroPython approach that gives us the core MicroPython modules and an LVGL module. To create a program, you add a display and touch driver to the flash drive, and you're ready. The second approach, pioneered by Kevin Schlosser, does the same, but includes many of the driver modules in the firmware. Programs using the second approach are faster. But since the firmware is limited in size, you must choose the drivers you want in the firmware. Also, this method best supports the ESP32S3 USB board with the 8 MB of PS RAM. Let's look at the Waveshare display and its components. Here, we see that the display uses the ESP32S3 USB module with 8 MB of PS RAM. That's good. The display uses the RGB 16-line parallel interface and uses a GT911 device for the touchscreen. Fortunately, the LCD bus supports the ESP32 chip and most of the components. So we will use this approach to build our firmware. Our GitHub site contains the firmware built for this video, so you do not have to build it. The CH422G driver component was missing, so we included the module that was written by Getzner H. We wrote a display driver that uses the firmware and flash modules. Put these into the flash drive, and you can run the desktop programs in Thony. Finally, we include a Docker file in case you want to build the firmware yourself. Let's walk through the build using the Docker file. There's also an instruction file in case you do not have Docker. The slide shows the two Docker commands. You're going to need about 20 GB of disk space for the resulting image and container. For video purposes, we are logged into a Linux system with Docker. We use the first command to build the firmware. Okay, let's look at the Docker file. The Docker file consists of several commands. First, it's going to pull Ubuntu. Then it's going to install all of the prerequisites. It's going to set the folder to home/Ubuntu, which is where we're going to pull a copy of the LVGL MicroPython from Kevin Schlosser's site. We'll then move our directory to that, and then we'll be ready to run the Python command. Let's perform the Docker. So the command is docker build -t, and then we want to give it the name of the image that we want, which is BLD UBU, and then we give it a dot to tell it to pick up the Docker file from this directory. Now we just wait for it to build. Okay, the build has completed. Let's clear the screen. Let's run the Docker command to create the container. It's going to be docker run and then -it for interactive. Then the name of the image, which was BLDUBU, and then we want to specify bash. Now connected to the container. We can look around just like we've logged into any Ubuntu system. And you can see we're already in the directory that we want to be. Okay, let's enter in the Python command to build the firmware. All right, you can see we've specified the ESP32 generic S3 board. The variant is SPI RAM _oct. That means the 8 megabytes RAM. We've specified the display of ILI9341, GT911, and XBT2046. The GT911 is one of the components of the Waveshare device. The RGB display will be built automatically with this make command. But we've added the ILI9341 and the XBT2046 in order to use this firmware for other projects. All right, let's hit enter. We had to interrupt the build, so this is the next day. No worries. Docker allows us to continue from where we stopped. The first thing I did was list out the images that I created yesterday. Then I listed out a list of the containers. Unruffled bins is the container that we want. Here we restarted the container, and we're back in the Docker container now, exactly where we left it. I did a midnight commander to look at the files there. Saw that we were in good shape. So Kevin Schlosser's command provides a means for rerunning the program in case there's a compile error or something. So you see, here's the same Python command we had before, but we add the word clean at the end. So let me highlight that so you can see it. So Python make the ESP32, our board variant, the displays, the indevs, and then the word clean. And then he's going to clean the build area. Let's just scroll through this. And it's going to go back out and start making sure that everything's been installed. So you see it's skipping some sections since it's already installed certain parts of this. Requirement already satisfied. That's good. Oh, here's a part that it missed, so it's downloading that and installing it. More parts that it's skipping. Here's another item that it needs to download. Notice that we're using ESP IDF 5.4, and we're using Python 3.12. Now it's doing the build. Generally, red messages are errors, but in this case, they're just informational. So we're good. Now we're getting the partition table. Oh, look, it's giving us the commands to install it. So it's completed successfully. So generally, I like to grab this portion right here of the build. It gives information on how to flash and I'll save that. We'll save that off to the side, and we'll include that in our list of files. Okay, so let's take a look at it on the using Midnight Commander now. So Midnight Commander is a textual way to look at your file system, and it makes it really easy to browse various different directories. So we want to look for the build directory, and in our build directory we'll see two files. This is the bin file, the firmware, and there's this partitions.csv that some systems need. So we include both of these in our GitHub site so that you have a copy of the working firmware. And that's it. We've built the firmware. You just need to SFTP this to your system. In summary, in this video, we demonstrated the simple fix and show it working. We discussed the two methods to build the MicroPython LVGL firmware. We discussed the Waveshare display and chose the LCD bus firmware approach to create the firmware. We walked through a firmware build using Docker. Hopefully, you learn more about the LCD bus and are thinking of ways to use it. Please comment if you feel other changes are needed. I hope this video helps your MicroPython coding. Thank you for listening.